Okay, guys, so we're going to calculate standard entropy changes. So instead of just looking at it from a relative, is it more, does it have more entropy or less entropy? We're going to actually look at the values of entropy changes. We're just going to do this in one technique, one method. It's really easy. So the standard entropy change, remember, so when you use the word standard, you got to include the little not symbol. So whether it's standard enthalpy or standard entropy, and so that's your standard. And your equation is real easy. It is the sum of the entropies of the products minus the sum of the entropies of the reactants. So very easy little equation to work with. My practice looks very much like a enthalpy change, that one technique for solving enthalpies. Subtract the reactants from the products. And so let's do an example. All right, so here is our problem. What is the standard entropy change for the reaction of two lithiums plus a chlorine molecule producing lithium chloride solid? Given, it should be given, the entropy of lithium is plus 28, the entropy of chlorine is plus 223, and the entropy of lithium chloride is plus 55. I do want to point out one thing here. Units are different than enthalpies. For enthalpies, we use joules per mole or kilojoules per mole. For entropy, it's joules per mole Kelvin. So just make a note of that. Make a mental note of that. It's going to be important later on. All right, so let's solve this. All right, so here's our formula. So we're just going to plug in. So the products, we're going to add the products. We only have one product, which would be lithium chloride, which has an entropy value here. And so that's going to be 55 kilojoules, I'm sorry, not kilojoules, joules per mole Kelvin. And then we're going to subtract from that the sum of the reactants. And so we have two lithiums. There's your entropy for that. So we need to do 2 times that entropy value. So 2 times 28. And we're going to add to that the chlorine. We have one chlorine. There's your entropy value for chlorine. So 223. And we need to make sure that we sum those before we subtract from the 55. And when you punch that into your calculator and solve, you get negative 224 joules per mole Kelvin. That is the standard entropy change for this reaction. Okay, and so that's it. There's nothing more to it than this, although I guess you could do a quick logic check to make sure it makes sense. So looking at your reaction up here, we have a solid and a gas turning into a solid, and so just logically, does the entropy increase or decrease? Going back to what we did a few days ago. Well, we're getting rid of this gas, this highly randomized or highly disordered gas. It's going away, and we're turning it into an ordered solid, and so entropy should decrease, which is why we have a negative entropy value for the change of this reaction. So at least we have the right sign here for the logic check of the reaction. And that's it.